You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcast. My guest is Sandrine Miller-Montgomery. Dr. Montgomery is the Executive Director of the Center for Microbiome Innovation, led by Professor Rob Knight at UC San Diego, and serves as a professor of practice in the Department of Bioengineering. So in that position, she's leading a team focused on expanding the industry and the academic collaborations. And they want to accelerate microbiome diversity and create technology around it. So, Sandrine, thanks for coming. How you doing?
I'm doing great. Thank you for having me.
Yeah. So, what got you interested in the microbiome in the first place?
Well, it happens that I'm someone who likes a lot understanding the big pictures and understanding big projects. And I stumbled, in fact, in microbiome across my career. I'm a scientist by training, moving toward the business side in biotech, and as I was moving within my career, I was looking mostly at the human genome. That was my background: human biology, human molecular biology, human genome. So microbes specifically were not in my radar, but I was using techniques that could be used for both human genome and microbe study. And so the microbes went to me in a way. And the first thing that intrigued me about microbiome was that it was the reverse of what has been studied so far in the microbe field. I mean, the microbe field has been studied for the bad bugs, the killer, the one that go and destroy food, and the microbiome is just the opposite of that. Is how to protect all of the good microbes that we were ignoring since then, and that's when my love for big picture and system study exploded towards microbiome, because you cannot touch anything in more or less the planet Earth without finding yourself confronted to the microbiome science, which was until very recently not looked at all.
Yeah, bacteria were just looked at as bad, and everyone wanted to get rid of them and have none of them, but they're essential for life. They're everywhere. So. Exactly.
And in fact, when you think about it, humans, we like to think that we are, very important on this planet, and to some extent we are. But what we tend to forget is that before we arrived, there has been millions of years where we were not there. But what was there was all the microbiome world, the bacteria, the fungi, the viruses, and during millions of years, they have time to adapt and evolve. And that's an amazing amount of diversity that is coming with all of these millions of years of evolution. And when you look at the tree of life, it makes us feel very, very tiny, because we are one tiny branch, despite all of our variety as Homo sapiens. But we are just one tiny branch of the tree of life, while most of it is used by microbiome fungi and bacteria, fungi, and viruses. So that was, to me, very humbling in a way, that we were not focusing enough on all of this diversity. Again, we were looking at the bad guys, but not the major population of the good guys.
Yeah. So how, it's weird. Bacteria can attack us. They can live with us. They can even, depend on us and make things for us, like serotonin in the gut, et cetera. Mm-hmm. How do you think there's that decision process, by the body, and maybe it's done in collaboration with our existing microbiome, like, how does our body, including the microbiome, how does it consider an outside bacteria or virus beneficial or a threat? Or do you think there's like a vetting process that not only involves our cells but our microbiome against outside creatures?
Well, in fact, I would like to reverse the table. I mean, is that we couldn't live the life we have without them inside us. In fact, when you realize that you have kids, for example, that have to be raised in aseptic zone or bubbles due to immunodeficiency, their development is affected, and one of the reasons because they are lacking this interaction with the protein with bacteria. You were mentioning, production of serotonin. There is a lot of production that goes into of component that goes into our blood that couldn't be there if we didn't have bacteria in our gut, for example. We couldn't have a healthy skin if we didn't have all of these healthy bacteria on our skin, for example, to combat the aggression of the environment. So they are essential to our health. And from birth, when you are born, virtually the baby is somewhat sterile. Even that's not completely true, but the baby is somewhat sterile. And as soon as it's getting exposed to the environment, these bacteria start feeding and the baby through the contact with the nurse and the parents, through the contact with the mother milk, for example, and later on with the regular food. All of these exchange are stimulating the seeding of humans by the environmental bacteria. And if you remember, the immune system is non-existent or very immature in the first 3 months of the life of a baby. So it's a perfect fertile ground for bacteria because they can enter the system and not be attacked. In return, it stimulates the immune system to start understanding what's foreign and what's not, and train the immune system for the kids when it grows up to be more protected. And in fact, we arrived to a situation where if you were to keep your kids, healthy kids, too protected from the environment by not letting them play in the dirt, for example, they will likely develop some lower immune response to their normal environment that can at some point trigger adverse events such as asthma or allergic reaction in the future when their bodies start being exposed to allergen that they were not trained to be able to handle in their early life. So it's important to understand that we get seeded and the body has been done so that there is this period where we are nearly welcoming, our body is welcoming all of these bacteria because we are unprotected by our own immune system. And in return, these start producing beneficial element that enables the kids to start developing.
Yeah, but I thought that babies are not born sterile, that if it's a vaginal delivery, that the baby is bathed in the mother's microbiome as it comes out.
Absolutely. Just before birth, they are somewhat sterile. And again, it's not absolute, but they are somewhat sterile just before birth. And now when they go through the vaginal canal and get in contact with the mom during the birth process, that's when they get seeded the first time. And this is something that we need to always keep in mind. For example, with babies that are born by C-section, where the skin of the mom has been aseptized to ensure that there is no later infection, these babies have a very, very delayed development of their microbiome. And we can see that in the very early days of their life, in the first 7 days, we have seen data showing that their microbiome is delayed and do not mature the way that a normal vaginally delivered baby's microbiome will develop. So you're right, they are not fully born sterile if they are vaginally delivered, which is the way nature does the first seeding. But some babies have that delayed by being born by C-section.
What's with the microbiome? It's not just in the gut. Do we see evidence that there's microbiome around every organ and every part of the body, or do you believe it's only centered in certain populations and certain spots in the body?
Well, the more we look, the more we find them. So I remember when I was a young scientist, I got trained that urine, for example, is sterile. Urine is not sterile. We just couldn't grow the bacteria and we couldn't observe them, but they were there, and now we can detect them with no question. The same applied to the blood. That's a myth that has been debunked recently, where the blood is sterile unless you are septic, meaning you have a bacteria that's taking over because you have a disease. And again, this is not true. We are detecting a bacterial signal in the blood, even in an healthy patient, a subject. And the same happened for the tissues. And there is a lot of discovery that needs to come up. But more and more, we find that tissues have their own bacteria embedded inside the tissues, the interstitial tissues. So the more we go, the more we realize that we are not a sterile entity, and it's usually it's for a very good reason. And there is this symbiotic relationship between the bacteria and the tissue or the organs.
Well, again, so in an adult, what do you think is the disease mechanism? If I'm an adult and I get exposed to a certain virus, the flu virus, and I get sick, what's happening? Is it just the old picture sounds like the virus would go into your body and, attack the cells. But we have this microbiome that we're so closely linked with, essentially we're a superorganism. I would think that the microbiome we have is actively participating in the defense of us because it threatens their existence too.
Absolutely. And in fact, one of the key examples we can use is with the bacteria, Clostridium difficile, which is what has been called, the bacterial disease of hospital, where people, for the longest time, we didn't know why. They were going in the hospital, they were getting treatment for their disease, and suddenly they were having this massive case of diarrhea that in some cases was lethal to the patient. And so it turns out that people thought that Clostridium difficile, that was a culprit, was in fact something that was growing in hospitals. A bacteria that was in fact in hospital. And it turns out that this is not the case. It's likely because when people go to the hospital, they get treated. A lot of them are going to get antibiotics. These antibiotics, most of our antibiotics are still very broad spectrum, non-specific. So they are going to kill the major population, the majority of your bacteria, leaving the place available for some other bacteria that could have been completely innocent in small amount, but then we can find a new niche because the most of the bacteria are now displaced, and they can invade the space, and that's what C. diff does. If most of the bacteria are gone because of an antibiotic treatment, when C. diff finds itself alone, it starts invading the place, leading to this detrimental episode of diarrhea, which again, as I mentioned, can lead to death. So it's a very serious disease. For the longest time, people thought that C. diff was not present in healthy subjects, but in fact, it is not in very high abundance and not in everyone, but you can be completely healthy and have C. diff. But again, you remove most of your bacterial complex by taking antibiotic, and then suddenly C. diff is going to take over. So it's a case where our microbiome is virtually protecting us from an invader.
Yeah, that's what I mean. How does it, when we're born, we have, a weak immune system, so the bacteria probably take up residence first. I would think they must. Yeah. I wonder if they guide the creation of the immune system and how they interact with it.
Absolutely.
Then when you're an adult and you have your your immune system, now you have these bacteria, these strains that have been with you for 10, 20, 30 years, let's say, 40 years. How do they treat or vet newcomers?
So technically, yes and no. So yes, you have some of these bacteria that are going to be there since you're born, but a lot of them are not, in fact, going to be there. When you're very young, until you are about 3 years old, you have a very immature microbiome with a very low diversity of the bacteria that you find in it. And based on the environment in which you grew up, a city or the countryside, based on your diet, you can be raised as a vegan or as an omnivore. Based on the contact, do you have a lot of friends at school with who you interact and play sport with, or are you homeschooled, for example, with more limited social exposure? All of that is going to impact the diversity of your microbiome. So the microbiome with which you are born is not going to be the same microbiome as when you are an adult. But along the way, all of these exposure are going to enrich your microbiome and are going to expose your body to positive stimulation. Again, the microbes are really going to be there to train your immune system and direct this host response in a positive way and train it so that when a pathogen, you were mentioning, the flu or other bacteria that are not welcome producing toxin arrive, then the body has already recognized something that is self versus something that's not self and can really activate the defense mechanism.
So, but again, how do you imagine that newcomers are vetted? If I change my diet, I know this, I've observed it, my microbiome composition of my gut changes.
Yeah.
What do you think are some of the mechanisms by which that happens? For instance, when you change your diet or as you age?
Yeah. When you change your diet, obviously you're depriving your existing microbiome population from their favorite food. And so that's if you starve your microbiome, well, some bacteria are going to leave your body, not die and be eliminated in your stool. And then these original bacteria are going to disappear, but you're still eating or else you would be dying. And what you are bringing with your food is likely new bacteria that are on the food coming either from the animal, from the plant, whatever the new diet introduction you have. And with these new bacteria and the new nutrient that you are bringing, a new generation and a new family of bacteria are going to come and receive the balance. So more or less when you change your diet, to summarize, you're creating a void of some bacteria, and that void, that niche, gets replenished by new bacteria that you get exposed to through your new diet. Most of the time, it's not going to have a major impact because it's not necessarily what the type of bacteria you have that's important in your gut, but it's what they are doing and their production. So you are mentioning, producing serotonin or producing short-chain fatty acid. To some extent, it doesn't have to be exactly the same bacteria that are present as long as they do the relatively same function. And that is a function, the way the bacteria are producing metabolites or proteins, that is going to be critical. So while they can change, as long as the function in what they are producing is relatively similar, the host can completely handle this variation.
Okay. So what's the focus of your research? What are you looking at in terms of the microbiome?
Well, I like to joke on the fact that if you find the focus of our research, please bring it back because I lost it a long time ago. We do not focus and it's done on purpose because microbiome is part of our environment, of our diet, of our buildings, of ourselves. We were mentioning the gut, the skin, the tissue, the blood, the mouth. We can't really walk in silo. And so that's what we are doing here at the Center for Microbiome Innovation. We have more than 130 PIs who are looking at microbiome from tons of different ways. So it can be tons of different domains, looking at the ocean microbiome, the soil microbiome, the plant microbiome, the food microbiome, obviously the human microbiome. That can be done looking at by different technology. Metagenomics, metabolomics, metatranscriptomics, and that can be done by in silico modeling, in vivo modeling, in clinical trial in human. So many different approach, and so on purpose, we do not create any specific focus. We don't want to create any silo because we understand that it's nearly a butterfly effect. If you change microbiome somewhere, a chain reaction is going to happen, and it will have a repercussion all over the environment in which you are studying. So that's our focus in a way. It's to not have a focus, but have a very holistic view of the microbiome research. And again, can be done from a computing point of view. Microbiome is a big data field. Or from a molecular biology point of view, from a cellular biology point of view, we do it all at the center, which I think make it a very rare place. And this is the reason why we are attracting a lot of industry partners. It's because we have this full panel of research angle that can fit some of their gap they may have in their own R&D portfolio.
Okay, so what in particular are you, if you don't have a specific focus, what are you studying about the microbiome right now? You must have multiple experiments running, I would think, right?
We do. We have experiments looking at microbiome and aging. We have experiments running about microbiome and schizophrenia, microbiome and depression, microbiome and diet, microbiome and ocean.
Let's start with some of them. Let's go into a little bit of detail. So, microbiome and aging, what kind of interesting things have come up?
Well, we're trying to predict your age using your microbiome, which is a fun exercise. And then with that, trying to define if you are exhibiting you as self a sign of early aging of your microbiome that could be associated with a disease, or if you have a microbiome that looks young for your age, which is likely a sense of resilience. So that's the kind of aspect we are looking at that as a potential biomarker for pursuing wellness as long as possible. And eventually, we are hoping that if the microbiome starts prematurely aging, maybe this is a sign that an adverse event is going to happen. Like, for example, if you are really looking in the aging population in house for elderly people, maybe we could detect ultimately that the fall is going to happen because the microbiome is starting to shift in a certain direction. So having a very proactive view of aging so that we could do early prevention, for example. So that's looking at it from the wellness, I would say, point of view. And we can look at it from a disease point of view when microbiome can be associated with some disease, some neurodegenerative disease, for example, like Alzheimer, and trying to see again if we can find an early sign, like a diagnostic tool in a way, a biomarker of something is going to happen, so let's be preventive. Or if it's a causality, can we modify the microbiome to avoid the progression of the disease or even cure the disease?
Well, how about with aging? Have there been studies where you've taken the microbiome of a young mouse and done a fecal transplant to an older mouse, and what happened?
Well, that we have not done specifically around aging. We have done that around obesity. When we were taking, in fact, the microbiome of an obese human, giving it to normal mice, and we were noticing that without changing anything, they were starting to get obese, while the twin humans who was having a normal body weight and was not obese, their microbiome was not making the mice go bigger. So we have this kind of study specifically for obesity. I think it would be likely a stretch, even if nothing is ever impossible, to say that, I'm going to get the fecal matter transplant from a young person and then suddenly I'm going to get younger. That would be extreme because, again, nothing is in silo. Your microbiome is communicating with your body. And if your body is 100 years old, you can put a fecal matter transplant of a 10 years old in it. Your body and your organs are still going to be 100 years old. So that's the things when there is a lot of buzz and vibe and over promises, and that's one of the things we are trying to avoid at all costs in our groups and center, is to make sure that when we define something, that there is no hype on the discovery, and that we are not fooling ourselves that we have probably resolved a piece of a puzzle, but there is still some things to unravel. So I wouldn't say that you can stay young by just changing your microbiome or doing a fecal matter transplant, for example.
I'm not assuming, that. I'm just wondering what would happen or what has happened and if you've experimented with it right yet.
Well, then I don't have the answer.
So I guess first, in terms of aging, what experiments are you doing or planning to do, and what kind of things do you want to elucidate in aging?
So
and just how the microbiome changes as you age? Or?
Yeah, so a lot of what we are doing is observational. So we look at people. We detail as much as possible coming from them or their caretaker. What are their habits, and try to get as many data surrounding their environment, their diet, and their weight, their height, their obesity level or non-obesity level, and then we map that compared to their microbiome. Some of that goes through the American Gut Project, which is a citizen project where a lot of what we call citizen scientists send us their samples so they can see how they compare on the map compared to people, for example, of the same age, compared to people with a similar diet or different diet or a different location in the world. Because even if you call it the American Gut Project, there is, in fact, we're now calling it the Microbiome Initiative because samples are not just from America and they are not just from gut. So it's compared to the initial project that was funded in 2012, it has broadly expanded to be above and beyond just American gut. So, but with this American Gut now part of a Microbiome Initiative, this is what we are doing. We are mapping because we are still in the phase where we need to observe. It's like having a GPS. If you have the GPS technology but you don't have a roadmap to superimpose it to, that's not going to be very helpful. Because you won't know if you can turn or not if there is no map telling you there is a building between your point A and your point B. So that's what we are doing. We are right now doing a lot of mapping. Along the way, we find some obvious differences. But the thing is, as I was mentioning earlier, that microbiome is a big data science, and it's very convoluted to get some clear observation. And there is, because you're looking at not one bacteria per person, but tens of hundreds of bacteria per person, diverse bacteria, diverse strain, et cetera, you need to analyze a lot of people to be able to see a pattern. And just to give you an example, if by just looking at your gut microbiome, I'm asking the question, are you a vegan or a meat eater? It's going to take me about, and if I do the study blind, 10 people being in one group and 10 people to be in the other group, so that I can say with a significant amount of confidence which you are a vegan or a meat eater. Now, if the question is a little bit more complex, such as are you male or female, it's probably going to take me 100 people in each group to be able to do that call with a very nice level of confidence. And these are easy questions. So now if the question is, are you 70 years old or 80 years old, or are you exercising versus not exercising, or sleeping versus not sleeping, that may require a lot of more samples sometimes to get to that level of confidence about making a call. And so it's coming from the power effect. So the more people we will be able to include in any kind of study, the better we will have a chance and confidence to find the answer to whatever is the question we are looking at.
Okay. And then have you figured out any mechanisms on how the microbiome works for the body, for instance, in disease and autism or other diseases? What's happening, what's causing the dysbiosis, and how's that interacting with our somatic cells?
It's going to likely depend on the disease. Some are a very direct effect. The microbiome will produce, let's say, a group of toxins that can be detrimental to the body. In some other way, they will be a normal microbiome would be producing a protective set of compounds that may go missing in certain segment of the population. And again, it will depend on your diet and your body itself. So it is really, you need to analyze all of that as a trifecta between or a set of three poles that you always need to consider. It's your own human genome and somatic cells, the environment, which is, the soil, the ground, the air you breathe, as well as the diet you get, and the microbiome. And all of that interact with each other through metabolism and production of different host microbiome reaction. And some of them will go very smoothly and be productive and protective. Some of them will be detrimental and create some accumulation of agent that may be bad. So there is still a lot of things to analyze. I was mentioning earlier the short-chain fatty acids, for example. In some segment of the population, it seems to have a clear positive effect and being beneficial. In some other segment of the population, this seems to be detrimental. It's not really clear if it's a cause or consequences, and so that's why we're still in a very early stage of the discovery.
Okay. So, what are some references for people to maybe get a test done on themselves to see what their microbiome looks like, and maybe get some insight into the various things that are in there and how that may affect their health? Any recommendations there?
Well, I would recommend first to go to a company or institution that are reputable, and there is a lot of bad company out there. Fortunately, there is some good one as well, and I will just let you listen to the press on that one, and the good and the bad one are very easy to recognize based on which agency are after them. So number one, so do your homework. Make sure that it's not too beautiful to be true, that their claim or the results that they proclaim they can deliver to you are sound science. One of the projects we have, the American Gut Project, is we are a non-for-profit. We work within UCSD. We really are looking at that as a way to provide science. The data are anonymized, but they are released in the public domain so that every scientist and every people can compare their data with each other in a public way. So while your privacy is protected, you have the benefits of being able to compare your data to whoever is already in the database. And I think we have more than 15,000 participants already. The numbers keep on growing. But again, we are doing that as a non-for-profit for science. And that would be something that I would recommend people to look for, entities that are really doing that for more or less science and the greater good, and entities that are doing that for self-profit.
Well, very good. So what's the best way for people to find out more about the lab you work in and your work?
Well, we have a website, which is cmi.ucsd.edu, because we are a UC San Diego entity. And if they are interested, we publish an external newsletter at least once or twice a month, and where we do summary of all of the good science and good press that we hear about. So if they want to sign up for our newsletter, this is on the first page of our website.
Okay. Well, very good. Well, Sandrine, I really appreciate you coming. Thanks for being on the podcast.
My pleasure.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.